Hello, this is Professor Michael Abbasi, and this is a topic on Linux and Mac forensics for my CIS 2008 forensics class. At the time of the recording, this is topic 7, and this is used in chapter 3 of volume 2 of the CHFI material. This may change, of course, over time, but the topic itself, Linux and Mac forensics. So yeah, that's the previous one we looked at, which is Windows Forensics. There is an order of volatility. It still applies to Mac and Linux, and it's much of the same stuff here. CPU memory, how the processes look will be different than Windows, of course, how you fetch those. But memory, CPU cache, you probably don't cache too much. Open files, network shares, slightly different way to collect these items. However, they are still, this is a volatile data up here. And down here we have the non-volatile. So there are some config files. There's some also app files, mostly config files. We'll look at those, and those are different for both Linux and Mac. Settings, there is something like a registry we'll talk about, and of course files themselves. Another one here I didn't add, a big one, of course, right here, and this is a big one for both, is logs. So logs is a big one. You want to have that. It was big on Windows. In Windows, it was the event viewer. We'll look at where that's at on Mac and Linux. Now, this chapter itself has a lot of tools to be ran. Gives you exposure to tools. I don't want to go into all the tools. I want to talk about more about where these tools are peeking into. So, um, uptime, things like that. You'll find that there are, of course, ways to get that from any tools. I want to talk about the more specifics for each OS. So, log files. So we'll look at Linux. The key thing to know here is that it's var log most of the time. Most of the time. It doesn't mean that there can't be a custom log file created. Um, and this is where you might look at a config file. If there's a config file for one-off, being open source, it's possible I can create an open source with C or C++ app that may be used nefariously by a suspect. And I don't write my logs to var log. I might write them to slash temp or some other area, or maybe in the direct, Now again, they usually might cause more problems than it will, because the infrastructure typically accepts var log as your default area to write logs to. Um, but if you're doing forensics for postmortem of a system failure, system was hacked, var logs would be your first stop. So we'll take a look at that. Now we're going to look at, here we go, here we have, now the list itself is good enough. I mean, you need to go to var log, but if you ls-l into var, var log, of course you can see there's a bunch of those here. Let's actually just make that just ls-l. So one of the main stops is usually your syslog or messages. Now it's going to depend upon the which operating system, which Linux operating system you're looking at. Last log's a good one. This is for boot information or dmessage. But auth log's a good one for people trying to attempt to log in or do specific things. It needs to be logged there. But I also want to note also here, for example, we have cups. This is a directory. If we were to go up here, we can see this is a directory in Linux. And as indicated by, go away, go away by the D right here. This D, that means this is a directory. So, and cups is an app. So sometimes if cups has a failure, maybe someone hacked cups. Cups is a common Unix printing service. So it's a print service for doing print servers. If someone may have done something with that, it's possible there would be a cups log written. But also the way logging usually works is it will write a copy to like your messages or syslog. Here's your syslog. And it'll have more detailed messages within the cups directory. So this is very common to see this. So var log, now it depends on the OS. In there, syslog or messages. Um, these are usually, and that's my chicken scratch my mouse here. It's going to depend on the, which Linux operating system, but if something is an app is running, a process is running, and it cuts us, it'll cut a copy to messages, usually for certain critical things, and then it'll cut either more detail to under the app itself. So var log, syslog. So it would depend on your OS. It's going to cut, maybe do a generic message here, and then maybe like here's this is called PS here. The PS directory might have further logs with greater detail. So being a suspect system here, let's do cups. Oops, C2 var. So we see there's access log here, error log, page log, and so on. Now, permission denied, of course, so sudo sudo less access log. There we go. Not that much here, of course. You can see pretty straightforward, or you can cat, but you might also see in our syslog. So again, there's a lot more insight here. And I'm just trying to show you that you might find some initially like high-level error messages cut to syslog or messages. This is based on the OS, the actual distro, um, and then underneath an app directory in varlog, you'll find more details. So keep that in mind. That's something that you might forget about. So let's move on here. So varlog is very important, and then we'll look at Mac. Mac has its own version of that. A couple of things here we look at for Linux. So there is the config directory. Using etc conf, or just etc itself. Here you'll see a bunch of .d or conf files, conf. Now they don't have to say conf, so the C is less cups dot. So cups conf. There's a directory for cups, and there's a cups.conf, cupsd.conf. All right. A note here. So this process, this PS application app, we call it cups. Let's say we saw it has its own directory in varlog, and then in the etc directory, you might find something in there that tells you how it's configured, and that might tell you where it's logging. So that's the key here. This might indicate where it's logging to. Everyone's gonna be different, so I don't want to say all apps do this, but at least you have a trail you can follow. So you can see locations information here and so on. So these configuration files are .confs are great to look at. Now they don't have to say .conf, they can just be the name of the file, like cupsd. And I'm just going to note, what does the D mean? So it means daemon. Anything that runs as a service, example like a web server, FTP, a VSFTP, and so on, or a print server like cups, will usually have a D on it. So cupsd.conf. So it's important to keep that in mind. So other thing too is the RC directory. When we look at specifics of Linux, things you might collect, of course, would be the date plus percent. I believe it's S. Yeah, so we have the epoch time. This is the time since a set time in 1970. It's like, which is, it sounds funny, but it's a real good way to narrow down the exact date time. But there's also other things in etc we can look at. I think it's time zone. So we can see what time zone you looked at. Cat host name. And I don't want to go through all these. These are things you're going to do in the lab. you'll run through manually. But the important thing too is sometimes this information can be harvested from an application. And but it's good to know where these applications are getting data from and summarizing it for you about your suspect's system. So, but Etsy's a great place. Etsy and Varlog, two good ones, and leave it there. And so, of course, other ones that we have is ifconfig, so we can see our network configuration, mount. I need a sudo mount. You can see all mounted drives of all types. Now, if you looked at mounted drives, you can see that the type is read write and so on. Now, some of these are virtual. So, like an example, proc. Let's talk about proc. Proc's a really fascinating drive. Now, this is something that is only alive. So, if I do a df-h, for example, we can see that there is a dev SDA1. So, it's important to understand devices in Linux. We know dev is the device directory, and which is also good to know about. SD is a SCSI or SATA attached drive. A is the drive itself, the first drive, and then 1 is the partition. So dev SDA1 is mounted on slash or root. So just a note on that, of course, slash in Linux is equal to our C backslash. So same as your C drive, but you can have other mount points. But you notice that there's some tempfs slash udev, tempfs. These are all memory-based file systems. So some of these are mounted to devrun and so on, but one of the important ones is proc. Now, proc is only going to be available for running live system. Chances are you can get everything you need from from other areas, but proc is a place you can get information about the kernel and its settings and current running processes, and that is laid out in a directory format. So for example, if I do ls-l on CPU info, ls-l of course is a long list. This is a 0 byte size file, so you would think it'd be empty. But if I do less on CPU info, it's got much information inside there. So this is like a live view, a live recording almost of all kinds of system aspects of the system. I know that the textbook talks about this too much. I just want you to make it aware of it. It has to be running, of course. You need a booted running system for proc to be available. When it is shut off, it's gone. But there is, of course, information like important proc files here. It could be something that might be good to know about. If you need more information about the system, um, like the exact build and so on, and you're not getting it from maybe the tool you're using, a third-party tool utility that's going over the system that can't find it, you might be able to get that manually. So that's a big proc up to that level. Some important aspects about Linux, of course, understand how the users work. Um, typically if you do ID or who am I, you can see what the user is. In this case, user James. You can see ID tells me I have user ID 001. That's good to know. And what group I belong to, or groups I belong to. I belong to a pseudo group and my own group, of course. Um, so good information there. Again, I don't want to go over every aspect, but I'll talk more about the directories. And an important one, of course, is going to be home directory. The reason why I'm mentioning it is it's good to become, if you know how to become root user, that could be handy because root has access to everything on Linux. But our home directory, for other users, you will see them listed. Now, if I'm user James and there's a user Mike here, and it's Mike, and maybe it's read only, that could be cause issues. So if I can get become the root user, so let's try sudo su dash, and look at that. So now I am root. Now if I go to /cd to home, any user on here, if there's James, Mike, Bob's, Sarah, it's all going to be available. So whether this is read only or it's marked out for the rest of the world as root, you can see everything. So going to James, you'll see each home directory has sort of a list of common things you would see on any file explorer here. So, pictures, music, downloads, documents, so on. There's a recycle bin, a trash bin in this case, and some distros will call them different things. But usually every user has their own home directory. And of course, for the non-volatile docs, non-volatile things like documents, definitely want to go here and look for that. Now, if the system has been shut off, there are ways to get this information. So we're going to move a little further ahead, and I'll come back and we'll look at that for also Mac. So Mac is Unix based. In fact, if the Mac is booted up and running, you can open a terminal, and you have just about the same. In fact, this is my system. This is not planned here. In this case, the users directory is very important, but ls-l, and you can see I have applications, database, documents, and so on. OneDrive, well, that's a good idea, right? If you were looking for suspect information, might have files at OneDrive, so you can get a subpoena for the college and get get this user Mike's files. Um, so anyways, there's terminal, and a lot of be the same. A lot of the navigation. Now, some underlying things are a little different, um, but it is a BSD based kernel. So, which really doesn't run too much, but where you collect evidence from will be a little different than that. So, um, there's no registry on Linux, but there's something called plists, P-L-I-S-T. plist files are almost like, um, they're like configuration files. So if I open terminal and I move it, let's say I move it over here and I close it and then I reopen it, it's in the same spot. So we know the registry on the Windows handles everything about Windows, right? Well, plist files handle that by the app, and they might be down in the core services area. So you might be able to find information about apps. So that metadata about an application might be good. So you can see here it talks about analyze these bundles, identify malware, suspicious data, timestamps are very important to look at. Um, so there are different areas for users, but this is the big one. Username, library. There's a library folder for the user that's going to uncover more information. Of course, the Mac file system, APFS, this shows the time. It actually has some metadata for files too. Of course, we can look at Spotlight. So Spotlight is sort of the search utility, and there are files you can harvest from Spotlight. It's a database, so you can view what kind of search has been done. Spotlight's like right here. So if I search for Linux, you can see it found files on my system. Maybe I use this to search. Here you go. Here's some Linux files right here. In fact, here's lab 2 for this class. So everything, open this file up has been logged, the search has been logged, and so on. So we do have var log on Mac. You can see here, for example, here's the cups. In fact, there's cups, access log, error log, daily out. Now, but there is a logged viewer also. And I'm not happy to be on a Mac here, so under utilities, you can find information on console. So the console itself has log reports here. So now we can tell this user has VMware on it. So that it could be handy knowing they run virtual machines. That could be that could raise your eyebrows. Like, wait a minute, they have virtual machines somewhere. We don't find any suspicious files on the regular home directory, but they have virtual machines. Ding, 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 right? So just seeing what we have, but here's access log. So very close to what we saw in Linux, and so on. So there's a console. Again, the textbook will go over these details here, but we also have other directories that we can dig into. Of course, we have those plist files in our preferences. So plist is a bunch of them. You can see what was attached devices. Maybe they have an attached external drive. Of course, .trash is hidden directory. Safari, if they use that for their main browser. Of course, we have the two other web browsers. So the user's home directory, library, application support. That is a good one to look at. This is a good place for your application metadata. Application support. So the library folder. And just by note, if you're going to do it on the command line, It is case sensitive, just like regular Linux. So um, cron tabs and stuff, it's possible you might have cron tabs running. This is a very, very, very Unix Linux level item here for cron jobs. Startup items. Some of the stuff you can glean from the OS if it's running, but if it's not running, you can also look for these files. Now, how can we do this? We can do this with a great tool here, which I actually have two things running and it's still analyzing those. This is, of course, Autopsy, which I don't know if we covered yet or not. I will say this is a fantastic tool. This is probably my go-to tool for have to deal with any kind of evidence files. So in this case, we have a Linux system, and it was been imaged. Again, very important. We go through the proper process, right? The the suspect's, it was drive was preserved. It was imaged over read only to a known clean drive. It's been hashed to verify it matches, and then the suspect device was put away, or in this case, let's say their drive or system or laptop stored away. And then from that copy, we might make a few copies of this image file, and here's the evidence file. So we can come in here, and we can see there's not much in proc here. Uh, it's empty, but again, we have, of course, our home directory. Here's our Etsy directory. So again, Etsy, here's our cron jobs, but we can also see here's cups, and we're back. So we can look at the cups.conf, and there's the text, which says could not be read. So if it could be read, we'd be able to watch it here though. Metadata about the file and so on. So we have the cups directory here. I mean the Etsy directory. I'm sorry, the Etsy directory. And of course, more important probably is going to be the slash home directory for the user. In this case, user Roger. And we see the hidden directories, cache, uh, Mozilla. So there you go. There's our web browser stuff. Um, there's a Mozilla directory right there. There's extensions, Firefox, and of course we have information about the web browser. I don't want to get into web browsers. We have a different lecture for that. But documents, right? So maybe they got some files here that are important. Okay, okay. Al-Qaeda hard disk. Okay. Well, that sounds like it might be of interest. And of course, we were looking back at the previous lecture, and of course, we actually have metadata for the files. And if it's possible, you can actually open this in a PST viewer, and then we could, of course, use this. It could be evidence. So we can view all the files here in the file in Autopsy. But also, if I look at under data sources, if I collapse that, I have Mac here too. So and there's our Spotlight. And of course, we have our Spotlight databases inside there, file system events, and so on. Private data here. Not much for the Mac one here, looks like. Songs, okay. Text files. So I think I attached the smaller DD image. But I want to show you that you can use this data sources here. And of course, if you have it running, now this is running and still analyzes Linux. So it takes a while to run. Of course, I added a second data source, and I even warned you, adding a second data source is going to make it run slower. So, but of course, encryption detected, suspected, it's a termless DB here. Of course, we talked about previously with mismatched files, so file extensions or file headers that are mismatched. So emails, things that might be of interest. Could be Outlook PST files. It might be you can extract those. So this is a fantastic tool, and more than this views and the results area, it's just the fact you can go in and we can view home or Etsy or var log. So you import var log, there's our log files. So if the system is shut down, we still got this non-volatile data we can go in and go and jump onto. So just want to show you that. So again, this actual chapter is a lot of there's a lot of look at step by steps for running different things. Command line, getting the date, the epoch time, ifconfig, and things like that. Especially for Linux, there's a lot of that here. So I actually um, I actually skipped over a bunch of that here. So again, I don't want to go through all this here. There's some we got some scripts you can run, Spotlight parser for Mac. But yeah, again, you can see how to look at an image file header. So, and you can do a lot of this in Mac. It's fantastic. I mean, on Mac also and Linux. But more important is, here's proc CP info, for example. So I go proc mounts. So again, proc's only available if it's running. So again, the chapter is fantastic. Look it over. I just don't want to go through every single one of these. It would take forever. But I think it's more important that we focus on what we can, um, the areas you want to look at. So first off, again, go back and think about whether it's any operating system. What's the volatile information I need to collect before I shut my system down or before it's shut down? And after it's shut down, there's some non-volatile stuff I can go to, var log, for example, /home, and so on. So think of the sources and their volatility. So walk away with that. So anyways, look at the module summary here. Again, yeah, we know about RAM contents. If all possible, get as much as possible if you have time. We talked about grabbing more logical sparses. So if time is of the essence and we think the user only use their home directory, there's no other, maybe go into /home documents and just grab that. You can image that over the proper imaging path and then later on do a full disk image. It takes time to do a full disk image. So sometimes those more logical snapshots of specific directories like the /user, uppercase U, like on Mac, I showed you there, right? All right, slash and uppercase U users, all users. You might be able to go into user mic documents and just grab that. Go into Linux, get this /home mic documents, and just grab that. So, but if that's for non-volatile. But if it's all possible, get the volatile data, RAM if possible, and then you can examine the files later on. They'll talk about SleuthKit, which is fantastic also. SleuthKit is great. So look at that. And look at the voluntary framework, helps you examine RAM stuff. This is some tools here you'll run. Actually, will grab Linux RAM and dump it for you. And there's some other tools, PhotoRec, or some recovery tools, the carb deleted files. So the chapter goes into that. I mean, the labs actually go take you into that too. So, and then Mac OS itself, of course, very similar in a lot of ways, just some slight differences. I again, I want to make sure you know that for Mac, it does uses the same as this site here. It's a slash, but we have .plist file. .plist files. These plist files, of course, the user library and the application support directories are going to have that information there. Okay, so I think I wrapped up enough here. Look over the chapter. Make sure you walk, read the chapter thoroughly. Make sure you walk through the labs. They're fantastic. And that will wrap up our topic 7 for Linux and Mac forensics.